You walk into a data engineering interview, you feel prepared, you studied SQL, cloud platform, you know your tools, you practiced. The interviewer looks at you and says, how do you manage your infrastructure? That's it. That's the whole question. No context, no details, just a vague, wide open question and silence. You give what you think is a solid answer. The interviewer nods, says okay, and moves on. You feel fine, but you just failed that question and you have no idea why. Welcome back, everyone. If you are new here, I talk about data engineering, analytics engineering, and how to build a real career in data. Hit subscribe so you don't miss what is coming. Now, let me explain what just happened in that interview. That question was vague on purpose, and it was vague for two reasons. First one, they want to see if you will reach the right tool, the right keyword, the right concept on your own, because eventually tools are here to solve problems, right? So they ask you a question, which is a problem in the infrastructure, data engineering space. So if you just answer with one word, that's more than enough and you will get the answer. The second one, and this is one most people miss, they want to see how you think. Are you going to just start talking, or are you going to pause, ask a clarifying questions, and narrow down the problem before you answer? Because most of the time they ask a very vague question, you have no idea how to answer. The tool just doesn't come up into your brain, right? You really need to ask clarifying question. If you got the answer, there is no need to clarify question. If you got it, that means it's vague for other people, not for you, because you know it. Say the answer, maybe 1-2 keywords, and then the interviewer, okay, he got it. Let's just move to the second question and you pass. That's the ideal situation. But if you don't, they want to see how you handle ambiguity, how you reach your conclusion, how you interact with the question, right? Because a real interview is not as we used to do in school. It is not question and answer. It is a discussion. They throw a big open question at you and give you the space to engage with it. Ask question back, clarify, explore. And if you are knowledgeable enough to drop the right keywords while doing that, that is the winning combination. Today, I'm giving you 10 of these questions, plus a bonus question at the end where I share a real story from my own interview where I knew the answer, but still lost the question. I want to see if you will succeed and answer that question. Trust me, you don't want to make the same mistake I did. So stick around for that one. And by the way, I put together a free PDF cheat sheet with every single question from this video, the weak answers and the strong answers, and all the keywords you need to drop. The download link is in the description, but watch the video first so the cheat sheet actually makes sense. And let's go. For every question, please do this exercise with me. Pause the video before I say it and let me know in the comment section how many questions that you got right. Okay, let's get started. First question, how would you get data from a source system into your warehouse? They are testing if you know CDC and modern ingestion tools. Don't just say I write a Python script. That is the junior answer. Say this. For a transactional database, I would set up a change data capture, CDC. This is very important. Using Debezium to read the database transaction log, and only the rows that changed get moved, not the full table every time. For other application or SaaS sources like Salesforce or Stripe or any other external sources, I would set a managed tool. Depends on the cloud platform that I use. So I can use a managed service or a managed tool like Fivetran or Terabyte. That's a side note here. You don't need to have the experience to work with such tool, but you need to be aware of these tools that exist and they solve this kind of problem. If you mention them, that means you understand the question, you understand the answer, but you haven't just got the experience to really implement this, because implementation is easy. The problem is how to pick the right tool, how to answer this question is the key. You don't really need to master or be an expert for all the tools here. It's impossible. But it's important that you mention the tools that is going to solve this problem. The keywords here, CDC, Debezium, Kafka, Fivetran, transaction logs, incremental loads, avoid full loads. That's the first question. All right, the second question, the transformation question. Once the data lands in your warehouse, how do you clean and transform it? Try to pause and answer the question. They want to hear DBT or data form. No pandas, no Python, not stored procedures, okay? If you say I use Python, pandas, they know you have never worked at scale. If you say stored procedures, they know you are stuck in 2010. The answer is I would use DBT, data form, if we are working in Google Cloud. They write SQL-based transformations, organized. Each model is version controlled, tested, and documented. I use DBT test for things like not null, uniqueness, and referential integrity. And I use the Medallion pattern, staging models, intermediate models, and final models. If you are in Google Cloud ecosystem, you say Dataform instead of dbt, same idea. So the keywords here that you need to drop is dbt or Dataform, SQL transformation, staging, intermediate, dbt test, Medallion architecture, version control models, etc. Now a quick pause. If these questions are already making you think, this is exactly why I built my coaching program. I help people break into data engineering and analytics engineering so they can crush their interviews. Link in the description to book a free call with me. All right, next question. The infrastructure question. How do you manage and set up your cloud infrastructure? At the beginning of this video, we mentioned that. They want to hear infrastructure as code, period. Never say I use the AWS or Google Cloud Console or I click around in the UI. That is the instant red flag. The answer, I use Terraform to define all infrastructure as code. Compute, storage, networking, identity and access management, everything. It's version controlled in Git, reviewed through pull requests, and applied through CI/CD pipelines. If we are using AWS, you can also mention CloudFormation, right, which is very similar to Terraform. It's infrastructure as a code tool, but Terraform is the safe, universal answer. If you just say Terraform at the beginning or infrastructure as a code, that's enough. So the keywords here, Terraform, infrastructure as a code, CloudFormation, Git, pull requests, state management, etc. Question number 4, the deployment question. How do you push code changes to production safely? They want CI/CD pipelines and deployment practices. If you say I SSH into the server and run the script, if you say that, the interview is over. I'm just laughing because I used to do it a lot. The answer should be like this. Every coded change goes through a pull request with code review. When it is merged, CI/CD pipeline in GitHub Actions or GitLab runs automated tests, venting, and then deploy to staging first. After validation, it promotes to production. There is no manual deployments. That's the answer that they are looking for. So the keywords here, CI/CD, GitHub Actions, GitLab CI, pull requests, automated testing, staging environment, blue-green deployments, etc. Question number 5, the history question. I love this one. How do you keep track of how data changes over time? They are fishing for, I think you got it, SCD, slowly changing dimension. SCD type 2 specifically. The question sounds philosophical. It is not. They want a very specific answer. You can say, I implement slowly changing dimensions for dimensions where we need history, like customer address or employee department. I use SCD type 2. Every change creates a new row with a valid from and valid to timestamp. The current row is flagged as active. This way, I can answer time travel questions like what team was this employee on when they closed that deal in March? Which team that employee was part of? Or what was the address of this customer last year? Something like that. If you just mention slowly changing dimension type 2, it's more than enough. That's exactly what they are looking for. The keywords here, SCD type 1, type 2, valid from valid to, is current flag, surrogate keys, dimensional models, snapshot tables, etc. Question number 6, the scheduling question. How do you make sure all your jobs run in the right order? I think this one is easy, right? They want orchestration. Airflow, Dagster, or Prefect. Don't mention cron jobs. You can say, I use Apache Airflow to orchestrate all pipelines as DAG. This is a very important keyword. Each task defines its upstream dependencies. If the ingestion task fails, the transformation task does not even attempt to run. If you want to sound modern, mention Dagster or Prefect as alternatives, but Airflow is still the most widely used and the safest answer. So the keywords here to drop, Airflow, Dagster, Prefect are not important, but you can mention them. DAGs, task dependencies, retries mechanism, orchestration. This is very important. Let's keep going. Next one, the real-time question. How would you handle data that needs to be available immediately? They want streaming architecture. You need to mention Kafka, event-driven, Flink, etc. If you say, I run my batch job every 5 minutes, this is not real-time. Don't say it, please. You can say, I would use Apache Kafka as the event streaming platform. Again, you don't need to use all these tools. You just have to have the awareness of these tools. I would use Apache Kafka as the event streaming platform. Producers publish events to topics in real time. On the processing side, I would use Apache Flink or Spark structured streaming to transform and aggregate events as they arrive. For late data and out of order events, I use watermarks and checkpointing to guarantee correctness. So the keywords here to mention Kafka, Google PubSub, Flink, Spark, structure streaming, event-driven. If you mention this, it's very important. Watermarks, topics. What do we have more? We have topics, producers, consumers, something like that. Dead letters as well. Question number 8, the data quality question. How do you know if your data is trustworthy? They want to hear testing and validation built into the pipeline, not I check it manually, okay? So if you say I spot check it in a spreadsheet, that will get you rejected for sure. You can say I write DBT tests on every model, like not nulls on primary keys, uniqueness on IDs, the accepted values on status columns, and relationships foreign keys. I use DBT source freshness to make sure raw data is arriving on time. If any test fails, the pipeline stops before bad data reach a dashboard. You just showed them you build systems that catch problems before humans. So the keywords to drop here: DBT test, not null, unique, accepted values, source of freshness, and SQL assertions, data contract. This is very important. Data contract is a game changer. Mention that. By the way, I recorded a video a few days ago about these concepts. I'll put the link here. You can watch that. I mentioned data contract. I mentioned streaming things. I think you will find it very informative. Check it out after this. All right, next one. The table format question. How do you store large-scale analytical data efficiently? They want modern open table format, not just in a database. This is a little bit advanced question, but it's fine. Generally speaking, if you just say in Snowflake or in BigQuery, that is fine, but service level. They want to know if you understand what is under the hood. You can say I use open table format like Delta Lake or Apache Iceberg on top of cloud object storage like S3 or Google Cloud Storage. This gives me ACID transactions, time travel queries, schema evolution, and efficient app search, all on cheap storage. It is the backbone of Lakehouse architecture. This tells them you understand the modern data stacks beyond just clicking buttons in a managed warehouse. So the keywords here to drop are Delta Lake, Apache Iceberg, Parquet, file formats, Lakehouse, ACID transactions, time travel, schema evolution, S3, Google Cloud Storage, GCS, object storage, etc. So these are the right keywords to mention. Question number 10, last one before the bonus. How do people in your company find and understand available data? They want a data catalog and governance tools. If you say, they ask me on Slack or Teams, congratulations, you are a human data catalog, and that doesn't scale. You can say, I set up a data catalog using tools like Data Hub, Atlan, or Unity Catalog. If you are using Google Cloud, you can say Dataplex. Every table has the documentation, ownership, lineage, and freshness metadata. Teams can search for datasets, see what columns exist, understand how the data is built, and check when it was last updated, all without contacting the data team. So this answer shows you think about the full data ecosystem, not just your own pipelines. Keywords here to drop are Data Hub, Google Dataplex, Data Catalog. Data Catalog is the most important one. Unity Catalog, metadata, data governance, data portal, data discovery, documentation, ownership, something like that. Now it's time to the last question, bonus, the event streaming question. This is the question. How would you design a leaderboard that updates in real time and keeps history? The context of it, there is a game or a company that develop games, online computer games, and this particular game has a leaderboard. Okay, so like the top 10 people that they're playing this game. Basically, they are looking to design a leaderboard that updates in real time and keeps history. Try to think about it and how would you design this? How would you approach this question? Pause the video and try to answer it. Let me tell you a real story. This actually happened to me in an interview. So basically, she asked me this exact question. How would you design a real-time leaderboard for a game? Okay, she explained the game, or basically she sent me a file that contains the description of this game and the company, and she gave me a few minutes to read it, and I read it, and then this is the follow-up question. So the question here is very vague. I did not really understand it because there is so many things that you can't talk about here. And the interview was about data engineering and a little bit in system design. Right? So that's why it's kind of, I don't know if it's a data engineering question. The question is 100% data engineering. I will explain after this. But here's how I actually approach this one. And I'm just sharing my experience so you learn from it. And I will give you the right answer after that. I will show you what I was thinking, exactly the things that I was going through, so you understand this kind of scenarios and you learn from it. Okay? First, I always against assumption. Don't assume anything. Always ask a clarifying questions. For me, it was very vague, but I did not assume. Let me tell you what happened. I actually asked first. I said something like this: with a cache database, because see, leaderboard in a game has to work with cache database. As mentioned, this was a little bit related to system design. That's why I mentioned the cache database, because that's the first thing that clicked into my mind when she said the leaderboard, right? Because it has to be cached, because it updated every second, right? It's impossible to really fetch this data from the database. So that's why I mentioned a cache database. I said with a cache database, we have very limited storage. So we need a mechanism to handle that, right? And she said, yes, exactly, continue. So what happened here, I got a strong yes, a green line to go into this direction. So I went all in. Cache mechanism, cache strategies, how you swap data between memory and the database. If you are familiar with cache, like cache invalidation and all these concepts with cache database or cache memory like Redis, I was going deep and I was explaining it very well. Just side note, it's okay if you are not familiar with cache things like that, but as mentioned, I expected a little bit because it was not really 100% data engineering, but the question is 100% data engineering. But halfway through, something felt off. So I stopped because I was actually explaining the strategies with the cache and all of this, how cache interacted, database, etc. I stopped and asked her, am I going to the right direction? She said, not really, but you are close. I was shocked. I thought I nailed it. And here's what happened to my brain. Because I got that confirmation earlier, I looked in, I blocked out every other possibilities. I knew it, this is the direction. Now I can talk for hours about this mechanism and all of this. So even after she told me I was off track, and she said, oh, not really, but you are close, I could not pivot. I could not switch the topic. I could not really think of any ideas other than that. So my mind was stuck on cache mechanism and databases in the back end, actually. Turn out she was waiting for one word, PubSub or Kafka, or any streaming tools. She wanted to hear that every time a player scores, we publish that event through PubSub and stream it into BigQuery for historical storage. This is an example. I'm using BigQuery PubSub as it was actually a Google Cloud environment. So the company are using Google Cloud. That was the answer. So the moment she said that word, I knew it. I understood it completely. I explained the full solution perfectly. After that, I asked her to give me a chance to really explain it because I went to different direction. PubSub for streaming, BigQuery for history, the whole pipeline. She wants to see how we are going to stream this data into the data warehouse. But just the question was very vague, even though I tried to ask the clarification question, but that did not help because I did not take the time to really understand. So the thing is this, you are not alone in any interview. There are other candidates and they are collecting data on every single one. So while I was talking, the keyboard was going hot. Basically, I actually knew that I was off a track because she stopped really typing that much. I thought, wait, she's not writing what I'm saying. That means there is something wrong, right? Actually, I got it from there. And that's why I asked the question, am I in the right direction? This is because of that. And you can actually recognize this. You will feel it. You will feel the interviewer. If he is already following up with you, he is interactive. And you can feel it if he's not. You can stop there. You need to really measure the temperature, okay? So she was writing because they are not allowed to use AI to summarize the meeting. They have to write notes, all the answers. Anyway, if the next candidate walks in and say pops up for the first 10 seconds, game over. They win. Even though I know the same concept, even though I explained it perfectly after she gave me the hint, the data says the other person got it faster, cleaner, and they collect data and data never lies. Well, it did in this case, but that is not how they see it. Here is the real lesson. One yes from the interviewer doesn't mean you have the full picture. She confirmed that cache is part of the puzzle, and it is, of course, but it was not the main thing she was looking for. So my point is this, don't ask one clarifying question at the beginning and assume you are set. Keep checking in throughout your answer, stay in dialogue, ask things like, before I go deeper into this, should I focus here or should I talk about how the data flows into the system first? Something like that. The moment you stop engaging with the interviewer and turn it into a monologue, it is the moment you risk going 5-10 minutes in the wrong direction, even with a yes in your pocket. So clarify early, clarify often, and say the keyword as soon as you can. For this question, the keywords she was looking for pops up: event streaming, BigQuery, real-time ingestion, historical storage.